All right, this is the balancing equations and types of reactions review, and it is just me kind of going over some information before your test since we'll have limited time in class. So, um, you will be expected to kind of look at reactions and figure out what type of reaction it is just by looking at it. So, with that thought process in mind, let me make that bigger again, sorry. Okay, we're going to look at these examples that I have here. So if we have just a single reactant, the thought process is really I recommend putting on your note card and or just thinking about it in that synthesis is going to always be two elements, okay, for our purposes as reactants. Decomposition, though, is going to be one compound as the reactants. Single replacement will be one element and one compound as the reactants. Then double replacement will be two compounds. And combustion will always be some sort of hydrocarbon, which will be some sort of compound that's got carbon and hydrogen in it. And so it could have some sort of values as their subscripts or not. It'll be either one. And oxygen. That's always what your for our purposes, what your reactants will be. So looking at these particular ones that I have down below, number one just has a single compound. So when we look at our list, this would be decomposition. Then when we look at number two, we have a single element of magnesium and a compound of HCl. So that would be an element and a compound, which would be a single replacement. All right. And then the next one, I have some sort of CH compound, which is a hydrocarbon plus oxygen. So that would be combustion. All right. I'll do it that way. And then the next one, number four, I have two compounds. So two compounds would be double replacement. And then the last one, I have hydrogen and I have oxygen, which is just two elements. So that would make that one be synthesis. All right. So now you're also going to be expected on the test to be able to predict the products. So when you have a decomposition reaction, the thought is that it's always going to break into its parts. So when I break into the parts of aluminum oxide, I will break into just the element of aluminum and just the element of oxygen. Now, oxygen is one of your H bronchlyphs, so you should make sure that you have that, you should know those. And anytime those are by themselves, they have to have a subscript of a 2. Then we would look at how to balance this, and so I have two ALs on one side, and I have one set of one AL on the other. So I would want to put a 2 right there to balance the ALs. Then with my oxygens, I have 3 on one side and 2 on the other. So I'm going to have to look for a common multiple between those, which would be 6. So to make 6 of those, I'll have to put a 3 there, and I'll have to put a 2 there. But in the process, that messes up my aluminums. So I'll then have to erase that 2. Now I have 2 times 2, which is 4 aluminums. So I'll need to put a 4 there. All right. So decomposition, you're just breaking it into its parts. Again, you can write any of these types of examples or anything on your note card. Now for a single replacement reaction, we really just want to, the first thing we always have to do is look at our activity series. And we have to see, is our single element magnesium higher than the element it wants to replace? Well, magnesium's a metal. And so in my HCl compound, all right, the only one of those that's on my activity series on my periodic table is hydrogen. So magnesium is looking to bump hydrogen out. So is magnesium higher on the activity series than hydrogen? And when you look, yes, it is. So this can happen. So that would mean that I could bump hydrogen out, and then I would have to look up magnesium's charge on the periodic table. And magnesium's charge is A plus 2 because it's an alkali earth metal. And then I have to look up chlorine's charge, which is negative 1 because it's a halogen. And then I would have to crisscross those charges. When you crisscross, you bring the number down and the charge itself of the plus or minus goes away. So I would create the compound MgCl2. Then after I do that, I would have to double check, is my single element that I have an H Broncliffe? And yes, it is. So I'm going to have to put a 2 on it as well. Now then, after I've done that, made sure all my products are written correctly, I've done my ion charges and crisscrossed for my compound, and I've checked if my single element is an H Broncliffe, then I've got to balance. So when I'm balancing, I have 2 hydrogens on my product side, so I'm going to have to put a 2 in front of the H cell on this side. That makes 2 chlorines, while I have 2 chlorines on the other side, so now I'm balanced. All right? For combustion, your products will be CO2 and H2O. Those will always be the products for the type of combustion reactions we're showing you guys. All right? So if that's the case, then we always also want to balance them in carbon, hydrogen, oxygen order. So there's 1 carbon on each side. Now there's 3 hydrogens on the other. Well, there's no way to get 3 out of 2. So we have to look for a common multiple. So we're going to put a 3 right here. And when we put a 3 right there, that's now going to mean we have to put a 2 right there. That means I have 2 carbons and 6 hydrogens. So in order to fix my carbons, I have to put a 2 there. All right? That would make my 6 hydrogens, so carbon and hydrogen are balanced. Now, when I have to count up my product oxygens. So 2 times 2 is 4. And then 3 times 1 is 3. So added together, those are 7. Well, then we have to think about what times 7, or what times 2 will give me 7. Well, the only thing that will give me 7 will be 3.5. Well, I can't do decimal numbers as coefficients. If that happens, what you need to do is you need to go to the beginning of the equation and you need to multiply everything times 2. So all the current coefficients you have right now, multiply them all by 2. So if I multiplied this first coefficient of a 2 times 2, then that would now become a 4. And then when I multiply 3.5 times 2, that would become a 7. And when I multiply the 2 times 2, that would become a 4. And when I multiply the 3 times 2, that would become a 6. So now I'm going to double check my count here. All right. So I have 4 carbons and 4 carbons. 4 times 3 gives me 12 hydrogens. 6 times 2 also gives me 6 hydrogens. Okay. Then I have to look at my oxygens. So I have 4 times 2, which is 8, plus 6 times 1, which is 6. 8 plus 6 is 14, and 7 times 2 is also 14. So that gives me the same amount all the way through. So now it is balanced. All right. Now, for our double replacement reactions, I do actually have a recommendation that of how to make sure, because it seems that y'all are struggling with who goes with who. So when you get a double replacement reaction, just go ahead and look up all of the individual elements or ions charges. So and write them to the side. So I have sodium, and I have hydroxide, OH, and I have magnesium, and I have chlorine. Now, sodium is a +1 charge because it's an alkali metal. And then hydroxide's a polyatomic ion, so we can look it up on the back of our periodic table, and it's a -1. Now magnesium is an alkali earth metal, and it is a +2. And chlorine is a halogen, so it is a -1. Now once you do this, the key thing to realize is you want to put the positive of this first one with the negative of this second one. So when I do that, I would get my Na with a +1 and my Cl with a -1. We always list the positive first, so that would give us NaCl when we do our crisscross. So we would put Na +1 and Cl -1 together. Move this up, and we would crisscross them down, and that would give us our NaCl. Then we would take the positive of the second one and the negative of the first one, which is Mg, 2 positive, and OH -1, and we would crisscross them. That would end up creating Mg, and then OH is going to need a 2 on the outside of it, which means it has to have a parentheses. Okay. Now we would look at balancing, and when we balance, we would say that there's one NH on both sides. Now there's one Na on both sides. There's 2 OHs on the product side. So I'm going to have to put a 2 in front of this NaOH, which means I'm going to have to put a 2 there to make the NAs correct. When I do that, that makes my Cls correct, so now it is balanced. All right? Then my last one is synthesis, and synthesis is just putting things together. So I'm going to look up my charges. So hydrogen is a +1 because it's in the first column on the periodic table, and oxygen is a -2 because it's in the oxygen family in column 6A. So then when we do our crisscross, we would have H2O. After we do that, we have to balance, which means we have to put a 2 here to balance our oxygens, which would mean we'd have to put a 2 there for our hydrogens. All right? So that goes over a large chunk of your test in the fact that you need to be able to predict products, you need to be able to balance, and you need to be able to tell me what type of reaction it is just from the reactants. Okay, so I'm going to go on and actually just talk about balancing a little bit more. So if I had this compound right here, or this reaction, first of all, what type of reaction is it? There's a single reactant, so this would be a decomposition reaction. It's always good to go ahead and do those things, even though the questions don't ask. And then we could balance. And this one, I believe, was the same one we did previously in our examples. Yeah, our original one. So we have a 2, a 4, and a 3. So we have a 2, a 4, and a 3. And so then I was asking what's the coefficient in front of the in front of the Al2O3? Well, that would be a 2. Now for this one, I have 2. We could make our list also if that helps you. Always, you can do that. You will have the time to do that on your test if you need to. So we have hydrogens. We have, well, it might be easier to balance our nitrogens first, because I always do recommend that you do hydrogens and oxygens last. So we would put a 2 in front of this one and then recount. So 2 times 1 is 2 and 2 times 3 is 6. So now to get 6 hydrogens, I would need a 3. 3 times 2 is 6, and now I would be balanced. So we asked for what the sum would be. So the sum would be 3 plus 1, because there's an imaginary 1 right there in front of the N2. And so that would be 4, and then the 2 from the products would be 5, 6. So the sum should be 6. I could also have asked you what are all the coefficients, and if I'd asked you for what are all the coefficients, it would have been listed as 3, 1, 2 as your answer choice that you would have picked. Okay? Then what is the coefficient in front of the MgCl in this reaction? So we would, again, go ahead and balance this. And so we have Mg, H, and Cl, Mg, H, and Cl. So we have 1, 1, 1. We have 1, 2, 2. So I need to put a 2 in front of here. Then I recount, which is 2 hydrogens and 2 chlorines, which now I'm balanced. So the coefficient in front is a 2. Then I have this compound, and so if I have Fe, Cu, and Cl, Fe, Cu, and Cl is the single replacement reaction, and iron is higher than copper on the activity series, so it can occur. There's 1 iron, 1 copper, and 2 chlorines. 1 iron, 1 copper, and 3 chlorines. So I have to look for a common multiple between 2 and 3, which is 6. So I'm going to put a 2 here and then recount. That's 2 irons, and that's 6 chlorines. Then I'm going to put a 2 here to fix my irons. Then I want to put a 3 here to fix my chlorines. So that would be 3 coppers and 6 chlorines. So then I would need to put a 3 here to balance my coppers on the other side. And it's asking for what is the coefficient in front of this part of my reaction, which that is a 3. And then finally, what's the coefficient in front of the O2? Remember, I did tell you to always balance these in carbon, hydrogen, oxygen order. Carbon, hydrogen, oxygen. So I have 1, 4, and 2. And I have 1, 2, and 3. So carbons are balanced, so to balance my hydrogens, I would need to put a 2 here. Then I need to recount my oxygens, because that would be, I have 2 in my first compound, plus 2 times 1 is 2, which makes 4 oxygens. So I need to put a 2 right there to make 4 oxygens. And it asks for what's the coefficient in front of oxygen, so that would be a 2. All right. And finally, this worksheet I gave you guys in class to kind of look at, and we can wrap it up with this. So each set of reactions is a type of reaction. So this one, set A, has compound, compound, and then we have a single product. And then it's, it's element, element, and a single product. Then it's element, element, single product. Then it's a compound and an element, but a single product. And then it's a compound, but a single product. If you always just have a single product is a synthesis reaction. So everything in this set is a type of a synthesis reaction. Again, the key part is a single product. All right. Then for this one, we have a single reactant compound, and we have a compound, Then we have a single reactant, then we have an element, Then we have a single reactant and an element, So anytime you have a single reactant, that is decomposition. Then in set C, we have a compound and a single element, and a compound and a single element. Then we have a single element, or a compound and a single element. And then we have a compound and a single element. And then we have a single element and a compound. And then we have a compound and a single element. So anytime you have a single element with a compound, that's going to be a single replacement reaction. And then in set D, we have a compound, and we have products of compound and compound. And so reactant, compound, product, compound. So anytime you have compound, that would be a double replacement reaction. All right? So then we were supposed to answer questions at the bottom here. And so it said the chemical equations in part 1 have notations. And we wrote these notations down. And so we would say that dissolved in water is the AQ notation. And the liquid would just be the L. And the solid would just be the S. And the gas would just be the G. Okay, we talked about what the arrow means. It means yields. We talked about what aqueous means. If you see that, that means that compound's dissolved in water. So, you know, we talked about a lot of these as we were taking our notes. Then also based on the sets above, which two sets typically involve ions that are dissolved in solutions. So we're really looking for a lot of AQs. There's a couple of AQs in synthesis. There's not any in decomposition. There's AQ there. So almost every one of these has an AQ in single replacement. AQ. Every single one of them in double replacement has an AQ as well. So the two sets would be set C and D. So single replacement and double replacement typically involve compounds that are dissolved in water. So just that's kind of one of those FYI things. Based on the sets above, which two sets of reactions typically involve gases and or solids? So we got a lot of gases here in the synthesis reactions and or solids. We got a lot of gases and or solids here in the decomposition. We have some solids in the single replacement reactions, but we don't have them in all of them. The ones we don't have solids in, we have gases, looks like. Then we always have a solid that is produced in the, we don't always, that's a bad word to use. So there's a solid there. That's just a liquid. So the double replacement doesn't always have a solid and or a gas. So again, which two sets typically involve gases and or solids? I would say that that is more synthesis and decomposition. So I would say A and B. Okay. Then just match each type with the description. Okay. Ionic compounds dissolved in water switching partners. So really, when you think about it, if they're switching partners, that's double replacement. It's another way to remember double replacement, which is set D. And then when one compound breaks into elements or smaller compounds, again, the key word here is one compound breaks into. That would be decomposition, which would be set B. Then you have two or more elements or compounds combine, and then the combining and the one product is your key here. So that is synthesis. Synthesis is A. And then part of an ionic compound is removed and replaced. So again, it's bumped out and replaced. So that is single replacement. So that would be set C. Hopefully this helps you. These are good pieces of information for you to review before your test. Have a good one. Good luck.